Hi guys, this is Dr. G here, and in this video we are going to talk about synthesis of aldehydes. So most of the reactions that we are going to talk about in this stage of organic chemistry uh, should be familiar to you. Why? Because in previous lessons or videos we have talked about some of these reactions in more detail. So my first recommendation is to go back and revisit those lectures or videos so that you will easily understand the reactions that I'm going to talk about in this video. Okay, so the first reaction that we are going to talk about for the preparation of aldehydes is the oxidation of primary alcohols using Des-Martin periodinane. Okay, so in this reaction, okay, one of the essential ingredients is a primary alcohol. So basically you are going to have to use a primary alcohol. So primary alcohols basically have at least two hydrogens in the alcohol carbon. Okay, so in here I have labeled the alcohol carbon. So alcohol carbon should have at least two hydrogens. Okay, two hydrogens for it to be a primary alcohol. So once you have a primary alcohol, you will treat this primary alcohol with Des-Martin periodinane. We call it DMP. So if you wanna take a look at the structure, I recommend that you revisit a previous video or your textbook. Okay, and then we could use a solvent like maybe dichloromethane. Okay, and what happens is that the primary alcohol group, which is this one right here, okay, the CH2OH, the primary alcohol carbon, will be oxidized to an aldehyde. So it will be oxidized to an aldehyde. So here is the remaining carbons, but the primary alcohol carbon will be oxidized to an aldehyde. Okay, so that is the reaction that we are hoping for. Remember, most of the times if you oxidize alcohols using a strong oxidizing agent, if you use a strong oxidizing agent like maybe dichromate or permanganate, this reaction will give you a carboxylic acid and not an aldehyde. Okay, so if you want to stop this reaction at the aldehyde, you want to use specific reagents. Okay, specific reagents, especially reagents such as DMP. Okay, so this is a reaction that you should know at this level. Okay, so in here what happens is that the primary alcohol carbon, which is the CH2OH, okay, will be oxidized to an aldehyde. Okay, an aldehyde. This is what happens. Okay, the primary alcohol will be converted to an aldehyde. So this is the first reaction that you need to know. All right, so the next reaction that we are going to talk about is a reduction. The previous reaction is an oxidation, of course. The next reaction that we are going to talk about for the preparation of aldehydes is a reduction reaction. For this reduction, you are going to need an ester. Okay, so you are going to need an ester, that is an essential reactant. Okay, so esters basically have a CO group, and then you have another alkyl group on the oxygen. Let's have a CH3 here. Okay, so let me use skeletal formulas. Or let's say CH3, that's fine. And then in here let's use another alkyl group, maybe CH2 CH3. Okay, so here you have an ester. Okay, here you have an ester. So right here you have an ester functional group. Here is the ester functional group. So for an ester, the reduction of ester is conducted by using diisobutyl aluminium hydride. Okay, we call it DIBA. Okay, so you can call it DIBA, or it is in long, it is diisobutyl aluminium hydride. Okay, so that is your first reagent. In the first step you will use DIBA. Okay, DIBAH, which is basically diisobutyl aluminium hydride. And then for the reduction, for the completion of this reduction, you will use an acid. Okay, so this particular reaction will get you an aldehyde. So here is your aldehyde, R group, CH3 CH2 COH. Okay, so the ester will be partially reduced. The ester will be partially reduced to an aldehyde. Okay, so this is the other reaction or the second reaction that we are going to study. Okay, so let me give you a generic example. All you need is an ester group. Okay, here is an ester group. Okay, here is your ester group, and then for this you are going to use diisobutyl aluminium hydride, and in the second step, for the completion of the reduction, you will use H3O plus. Okay, so in here what happens is that you will get your R group as is, but the ester group will be reduced to an aldehyde group, all right. So that is the second reaction that we will commonly use to prepare aldehydes. And the next two reactions should be very common to you. Okay, so the third reaction, I'm going to use the ozonolysis reaction. Okay, so if you remember the notes from alkene, okay, okay, ozonolysis is basically an oxidation reaction. Okay, and for this reaction you are using ozone. Okay, you are using ozone. So let's take an alkene. Okay, let's take an alkene. Oops, sorry. Let me change the color. Let's take an alkene, but when you're taking an alkene, always remember to use a monosubstituted or unsubstituted alkene. Okay, so let's take an alkene like this. Okay, for this alkene you will use ozone in the first step. Okay, O3, and in the second step you are going to need zinc. Okay, so these are the reagents for the ozonolysis reaction. So you should know this by now from your alkenes lesson. So what happens in ozonolysis is that you're going to cut through the double bond. Okay, you're going to cut through the double bond. Okay, so your double bond is now cut in half, right? And what happens is that the ozone will add an oxygen each. I'm sorry about that. Let me use a different color. So once it is cut through the double bond, you're going to have two molecules like this. Okay, but from the locations that you cut the molecule, you are going to put an oxygen. Okay, you are going to put an oxygen. So of course in ozonolysis reaction you are going to get different kinds of products. Especially you are going to get aldehydes and ketones. But in this discussion we are more interested in the aldehyde product, which is the one at the bottom. Okay, so this right here is your aldehyde. To get that aldehyde, okay, here is your aldehyde. So to get to an aldehyde, you better have a carbon. I'm going to highlight the carbon. You better have a carbon that is unsubstituted or monosubstituted. Okay, so if a carbon is disubstituted, like this one, this carbon right here is disubstituted. If you have a disubstituted carbon, you are going to get a ketone. Okay, you are going to get a ketone. For this discussion we are more interested in the aldehyde. Okay, so this is a nice reaction that we learned in much more detail before, but I hope that you guys remember it now. Okay, and the last reaction that we are going to talk about today is another very familiar reaction to you. Okay, this is hydroboration oxidation. Okay, so this reaction is hydroboration oxidation of terminal alkynes. This reaction is hydroboration oxidation of terminal alkyne. So what are terminal alkynes, guys? In terminal alkynes you have the triple bond and at one of the ends of the molecule, right? So let's have a terminal alkyne. Okay, let's have terminal alkyne. There we go. So in here I have 1 2 3 4 5 carbons, and this is the terminal alkyne, right? So during hydroboration oxidation, the reagents that you use is you will use BH3 in the first step, and you might need a solvent like THF. And then in the second step, you are going to use the oxidizing agent, which is the hydrogen peroxide in basic medium. Okay, so by now these reagents should be very common to you, okay? Because we have talked about these things in previous lessons. So basically what happens is that hydroboration is an oxidation step, but the regiochemistry of hydroboration is actually anti-Markovnikov. Okay, so this is actually anti-Markovnikov. Okay, so which means in Markovnikov rule, what happens is that hydrogen goes to the carbon with more hydrogens, right? So if you remember, hydrogen is like money. It prefers to go to the carbon with more money, right? So hydrogen goes to the uh, carbon with more hydrogens in Markovnikov rule, but this hydroboration is actually anti-Markovnikov. That is important to remember, okay? So regiospecificity or regiochemistry is anti, or we can call it non-Markovnikov, okay? Anti-Markovnikov. Anti-Markovnikov. So in anti-Markovnikov means the hydrogen goes to the poor carbon or the carbon with less hydrogen. So in here, the carbon right here is your poor carbon. This carbon is your rich carbon. Okay, so since this is anti-Markovnikov, the hydrogen goes to the poor carbon, and of course the oxygen goes to the rich carbon. Okay, rich carbon. All right, so the product will be, this is the 5-carbon chain. This is a 5-carbon chain. So 1, 2, 3, 4, 5. Okay, and then the poor carbon gets the hydrogens, rich carbon gets the oxygen. Okay, rich carbon gets the oxygen. So this right here is your rich carbon, by the way. Okay, and here is your poor carbon. These are hypothetical. Don't go writing PNR everywhere. Okay, but this is anti-Markovnikov. So oxygen goes to the rich carbon. Okay, so the poor guy gets some money in this case. Anyway, so this is a very specific reaction. You have to have a terminal alkyne. Okay, you have to have a terminal alkyne. That is important. And then hydroboration oxidation will give you an aldehyde. So this is an anti-Markovnikov. That is why it will give you an aldehyde. Once again, guys, let me ask you another question. What do you know about the, I mean, it is not relevant to this one, but what do you think about the stereochemistry of hydroboration oxidation? Is it syn or anti? Actually, hydroboration is syn. Okay, it is syn addition. Just reminding you what we learned before, okay? You don't have to worry about that here. But these are the characteristics that we learned about hydroboration. By the way, the people who prefers to learn things graphically, what happens is that in hydroboration, you are hydrating the triple bond. So basically the oxygen goes to the rich carbon, the 2 hydrogen goes to the poor carbon. Okay, that is exactly what happens. Okay, so the oxygen goes to the rich carbon, the 2 hydrogens of the water molecule goes to the poor carbon, goes to the poor carbon. So you're basically splitting it in the middle. Poor carbon gets the 2 hydrogens, rich carbon gets the oxygen. With that, I'm going to conclude this video. If you guys have any questions, just send me an email or make a comment. All right, you guys have a nice one. Okay, have a good day.